Hi friends, welcome to all. In this video, we are going to configure SRWE Practice PT Skills Assessment Part 2. Friends, please share, like and subscribe our channel. And also if you wish to get any technical support, you can contact our team. All the details given in the description below. Here coming to our activity, here we can see our addressing table. Here we have IPv4 and IPv6 addresses. We will see the objectives. In this assessment, we will configure the following: floating, static and default routes in IPv4 and IPv6, host routes in IPv4 and IPv6, then DHCP pools and scopes, then switch security including port security, enhanced LAN security with the DHCP snooping, dynamic ARP inspection, port fast and BPDU guard, wireless LAN controller based wireless LAN with the enterprise authentication. So these are the objectives of this packet tracer activity. We will only configure the RTR-HQ. So here we can see that router and RTR branch routers. Then the SW1 switch and the WLC10 wireless LAN controller. Access to other devices is not available, because all other devices are already configured here. So we need to configure only these devices here. Background: XYZ Corp is reworking their network. You have been asked to prototype the network in Packet Tracer for evaluation by senior network staff. Okay, here are the instructions. Part 1, configure switch security. In this part of the assessment, we will configure switch SW-1. So here we can see that switch with the switch security features. Then switch ports fast Ethernet 0/1 to 5 are the active switch ports. Port gigabit Ethernet 0/1 is a dedicated link to router RTR-HQ. All other ports should be secured. We will do it one by one. Configure VLANs. Configure VLAN 10 with a name users. Then configure VLAN 999 with the name unused. Okay, we will do that in this switch SW-1. Enable configure terminal. Here we will create the VLAN 10 and the name is users. Also we will create VLAN 999, name is unused. Step 2, configure active switch ports. On the active switch ports, configure the following: configure fast Ethernet 0/1 through 0/5 and a gigabit Ethernet 0/1 as static access ports in VLAN 10. Okay, we will do that. Coming to SW1. So here we will go to those interfaces as a range FA 0/1-5. Also we need to go to G0/1. Switch port mode access. Switch port access VLAN 10. Activate port security on the ports. Configure the active ports to accept a maximum of 4 MAC addresses. If a violation occurs, configure the ports to drop frames from the unauthorized MAC address, log it and send an alert. Then MAC addresses should be present in the MAC address table for a maximum of 10 minutes before they are removed. Then ports should add the learned MAC addresses to the running configuration. Configure the MAC address of host 1 as a static address on port fast Ethernet 0/1. So we will do all these 5 configurations now. Coming to the configuration, we will go to interface as a range because we need to go to FS0/1 till 5. We are not giving a G0/1 because we can see this interface G0/1 is connected to the router at RTR HQ. So we are going to configure only the interfaces which are connected to the end devices. Okay, now we will enable port security, switch port security. Okay, now we will set a maximum of 4 devices. Switch port security, maximum 4. Okay, switch port security, violation. Here we can see they specified. So drop frames from the unauthorized MAC address, log it and send an alert. So here we must use restrict. Then we will set aging. Switch port security, aging time as specified at 10. Switch port security, MAC address sticky. Next is configure the MAC address of host 1 as a static address on port fast Ethernet 0/1. So we get the we should get the MAC address of this host 1. So IP config space /all, so that we can see this physical address. I will copy that. Then coming back to SW-1, we will go to interface FA0/1, and here switch port security, MAC address, and that host 1 MAC address already we copied. We will paste here. Okay, and press enter. Next is C, protect against DHCP snooping. They given a note. In this simulated network, DHCP snooping may not operate correctly in packet tracer. Configure it as you would normally. You will receive full credit for a configuration that meets the requirements below. Okay, we will see the requirements. Activate DHCP snooping globally. Then activate DHCP snooping for the 2 VLANs that you configured. Then configure the ports to limit the rate to 5 DHCP packets per second. Then configure the port that links to the router as a trusted. Okay, so we will do this configuration. Coming to our switch. So we will go to global configuration mode. Here we will give IP DHCP snooping. Then IP DHCP snooping VLAN. We created VLAN 10 and 999. Okay. Now we will go to interface as a range FA0/1-5, also G0/1. And here we will give IP DHCP snooping limit rate 5. Exit. Then we will go to interface G0/1, which is connecting to our router, and here we are going to configure the trust. IP DHCP snooping trust. Next we will go to D, guard against ARP attacks by implementing DAI. Activate DAI globally, then activate DAI on the 2 VLANs. Then configure the port that links to the router as a trusted. So we will do these three things here. In the global configuration mode, IP, ARP, inspection, VLAN, VLANs are 10 and 999. Then we will go to interface G0/1, IP, ARP, inspection, trust. And finally here E, mitigate STP attacks by configuring BPDU guard and port fast on the active ports. That means on this FS0/1 till 5, right? We can do that. So we will go to those interfaces as a range, that is FS0/1-5. We will give a spanning tree port fast. Also we will give a spanning tree BPDU guard enable. In step 3, a secure unused switch ports. Move all unused switch ports to VLAN 999. Yes, we already created VLAN 999. Configure all unused switch ports as static access ports and deactivate all unused switch ports. Okay, we will do that. We will go to interface as a range and the interfaces which are not using. FA0/6 till 24. G0/1 is already connected to the router and G0/2 is not used. Switch port mode access. Switch port access VLAN 999. Now we need to deactivate all these unused ports using shutdown. Now coming to part 2, configure addressing and DHCP. We will configure DHCP and interface addressing on router RTR branch to prepare for implementing the wireless LAN controller and network. Okay, step 1, configure and address a sub-interface for the wireless LAN user network. So configure sub-interface 10 on the router interface that is connected to the switch SW-4. So here we can see that RTR branch. So the router should provide a router on a stick inter-VLAN routing to VLAN 10. Configure the sub-interface with the address from the addressing table. So coming to our addressing table, RTR branch. So here we can see RTR branch and we can see the sub-interface G0/0/0.10. So here we need to set this IP address 192.168.10.1/24. So we will do that configuration now. We will go to RTR branch router. Enable configure terminal. We will go to interface G0/0/0.10 sub-interface and we can set a description if needed. So this is for branch LAN. Now encapsulation .1Q VLAN ID is 10 and we will set the IP address. As per the addressing table, it is 192.168.10.1 and the prefix given /24. So the subnet mask is 255.255.255.0. Step 2, configure a DHCP pool for a WLAN user network. Exclude the router interface address and the management address of the WLC. Okay, we can do that. So we can verify that address here in the addressing table. So obviously that 192.168.10.1, and for the wireless LAN here we can see 192.168.10.254. We will exclude these two addresses here in this RTR branch. Okay, we will exit in global configuration mode IP DHCP excluded address 192.168.10.1 and also IP DHCP excluded address 192.168.10.254. Then configure a DHCP pool that will be used by hosts that are connecting to the wireless LAN. So name the pool WLAN host. Okay, we will create this DHCP pool. Then configure the pool to use addresses in the 192.168.10.0/24 network. The pool should also provide the default gateway and DNS server addresses. Okay, we will default gateway is already 192.168.10.1 and the DNS server address we will get from the addressing table. Here we can see that 198.51.100.163. So we will configure this in our RTR branch router. Coming to router. So we will create IP DHCP pool. So pool name they specified WLAN-host. So network is 192.168.10.0. Then subnet mask. Okay, then we will set the default router gateway, that is 192.168.10.1, and also we will set the DNS server. So it is 198.51.100.163. 198.51.100.163. Step 3. Configure an interface as a DHCP client. On RTR branch, configure the interface that is connected to cloud router to receive its address over DHCP. So we can see here the interface is G0/0/1, which is connecting to our cloud router. So we can do that. We will go to interface G0/0/1. Then we will give a IP address DHCP. Yes, so here we can see immediately DHCP address is assigned 10.3.0.2 and here we can see the subnet mask. Next we will go to part 3, configure static routes. In this part of the assessment we will configure static, default, floating static and host routes in both IPv4 and IPv6. We will configure the RTR HQ and RTR branch routers. XYZ Corp has decided that it wants to use static routing between all its network. In addition, the company wants to use the Ethernet links between routers for most data traffic and reserve serial link between RTR HQ and RTR branch for backup purposes in case one of the Ethernet links become unavailable. We will be configuring floating static and default routes. We will do that. Step 1, configure static routes on RTR HQ. Configure IPv4 default routes to the cloud using the Ethernet link as the preferred link and the serial link as the floating backup. Use an administrative distance of 10 for the backup route. These routes should be configured as directly connected routes. They given a note, Ethernet interfaces will give a warning when configured without a next hop address. In this configuration, the interface is point to point, so the warning can be ignored. Okay. So here we are going to configure this router RTRHQ towards cloud. Here we are going to configure this static route through this interface G0/0/2, and also we will configure the backup route, that is floating static route through this serial interface towards cloud. That is, let me see this interface, serial 0/1/0, and we need to configure with the administrative distance of 10. So whenever this link between RTR and cloud router fails, these all networks can go to this cloud through this interface serial 0/1/0. I mean through RTR HQ, then RTR branch, then it will go to cloud router and cloud. Coming to the configuration in RTR HQ, enable configure terminal, we will set the IP route, default route 0.0.0.0 space 0.0.0.0 space, then exit interface G0/0/2. We already have seen that. Okay, default route without gateway, no worry. If not, a point-to-point interface may impact performance. Okay. Now we will configure the floating backup route, IP route 0.0.0.0 space 0.0.0.0 space. So our exit interface is serial 0/1/0, and the AD as they specified to use 10. Ensure that the device is configured to route IPv6. Okay, so we will give that command, that is IPv6 unicast routing. Configure IPv6 default routes to the cloud. Use the Ethernet link as the primary route and the serial link as the floating backup. Use an administrative distance of 10 for the backup route. Yeah, same like IPv4 we have done. These routes should specify the next hop interface address. Yeah, so here we are not going to use the exit interface. Instead, we need to use the next hop IPv6 address. We will do that configuration. So here IPv6 route :/0. Then we need to specify the next hop IPv6 address. Here, the next hop IPv6 address using this cloud router, it will be the IPv6 address of G000 in this cloud router. So we will get the IPv6 address from the addressing table, cloud router. Here we can see. So let me copy this IPv6 address, G000 interface IPv6 address, and we will use here as the next hop IPv6 address. Now we will configure IPv6 route :/0 IPv6 default static route. Then we must specify next hop address through this router RTR branch, floating static route. We should get the IPv6 address of this interface serial 0/1/0 on this router RTR branch. So RTR branch, here we can see RTR branch serial 0/1/0. Just I will copy this IPv6 address from the addressing table. Okay, so we can go here, paste it. Now we need to specify the AD, administrative distance, because this is floating backup route. So a specified AD is 10. Next is configure IPv4 static routes to the branch LAN WLAN. Okay, user network following the same guidelines as above for type of route and administrative distance. Okay, now we are going to configure static routes, not default routes. So we are going to configure this static route towards this wireless, that is branch LAN. Okay, so we need to follow the same thing. It should go through primary route will go through this cloud router, and the backup route will configure through this serial interface. So we can do that in RTRHQ. IP route, then our remote network is here 192.168.10.0. 192.168.10.0. Then submit to mask. Then we will specify the exit interface G0/0/ I need to verify our exit interface 2. Okay, then we will configure the backup route, IP route, same network 192.168.10.0. This is for the WLAN. Then 255.255.255.0. Then exit interface through this serial 0/1/0. Then our administrative distance, they specified 10. Here next is configure IPv4 and IPv6 host routes. IPv4 and IPv6 host routes on RTRHQ to the office server on the office LAN. Okay, we should get the IP address of our office server. Create a directly connected route for IPv4 and a next hop route for IPv6. Okay, that can be done. So we will get the IP address of our office server. So here we can see IPv4 address 192.168.3.122. Just I will copy that. Then coming to our RTR, and here we can see the exit interface. So we need to configure using exit interface. So it is serial 0/1/1 towards this office LAN, office server. So we can do that. IP route, that IP address I already copied. Then we need to give all 255 because we given here the IP address, not the network address. Then exit interface serial 0/1/1. Also we need to configure for IPv6 route. So we should get the IPv6 address from our office server. Okay, just I will copy it. Then prefix we need to give 128. Now we need to specify our next hop IPv6 address. So we will get that from our addressing table. Here the next hop will be the IPv6 address of this interface serial 0/1/1 on RTR office. So we'll go to RTR office. Here we can see. So let me copy this IPv6 address. Okay, coming back here, I will paste it here. Next, in step 2, configure static routes on RTR branch. RTR branch must also be configured with static routes to the other 3 networks in the XYZ Corp network. It will require a floating static and default routes in IPv4 and IPv6, following the same guidelines as were used for the RTR-HQ static routes. IPv6 routes use next hop address arguments. IPv4 routes use exit interface arguments. All routes should prefer the Ethernet links over the serial link. Then backup floating routes use an administrative distance of 10. So this whole instruction we done previously, same thing we need to follow here also. So configure IPv4 default routes to the cloud using the Ethernet link as the preferred link and the serial link as the backup. So we will do that. So here we will go to this RTR branch, and Here they specified use exit interface. Here it is G0/0/1, and there is a backup route. Exit interface will be serial 0/1/0. Okay, perfect. We will go to this router, enable, configure terminal, IP route 0.0.0.0 space 0.0.0.0 space exit interface G0/0/1. Okay, now again IP route 0.0.0.0 space. Okay, then exit interface is serial 0/1/0 with the administrative distance of 10. Ensure that the device is configured to route IPv6. Okay, that command is very important. IPv6 unicast routing. Configure IPv6 default routes to the cloud. Use the Ethernet link as the primary route and the serial link as backup. Okay. Use an administrative distance of 10 for the backup route. These routes should specify the next hop interface address. So we will do that too here. So IPv6 route :/0. Now we should get the IPv6 address. I mean the next hop IPv6 address. The IPv6 address of this interface G0/0/1 on this cloud router. So we'll go to cloud router. Cloud router, verify the interface G0/0/1. Just I will copy that. Then coming back to our router and paste here. So now we have our next hop IPv6 address. IPv6 route 0. This is our backup route. So it should go through the serial interface. Next hop IPv6 address. The IPv6 address of serial 0/1/0 on this RTR HQ. Okay, serial 010. Yes, I will copy this address. Paste here, and then we need to give the administrative distance 10. Next, we will move to part 4. Configure a wireless LAN using a wireless LAN controller. In this part of the assessment, we will configure the wireless LAN controller to provide wireless access to the network. Username and password are the default admin. Username is admin and the password is also admin. Connect to the WLC over HTTPS to the management interface. Step 1. Configure a VLAN interface. Create a new interface and name it WLAN 10. The interface should use VLAN 10 and physical port 1. So first we will log into our wireless LAN controller. So we should know the IP address of our wireless LAN controller. Management, here we can see WLC management 192.168.10.254, the last address. Okay, so we will go to our management host web browser, and here they specified we should use HTTPS. Okay, then the IP address of our wireless LAN controller 192.168.100.254. So login, username is admin, password also admin. Okay, now we will create the interface. We need to go to controller. Then we can see interfaces. Here we will create new interface. Then we will give an interface name as WLAN 10 and VLAN ID 10. Then click on apply. Here this port number is 1 already they specified. Now we need to give IP address, net to mask, gateway and primary DHCP server. Okay, here your addressing table we can see that wireless LAN 10. We can see the address 192.168.10.254/24. We will configure it. 192.168.10.254. Then net to mask. Then gateway, it is a 10.1, 192.168.10.1, and our primary DHCP server gateway address 192.168.10.1. Then click on apply. Okay. Use the information in the addressing table to configure the addressing settings for the interface. Yeah, we have done that. The interface will be using a DHCP pool that is configured on the sub interface that is assigned to VLAN 10 on router RTR branch. Yes, because our DHCP server is a RTR branch and we configure the sub interface with IP address 10.1. Hence, we configured here this primary DHCP server as this RTR branch sub interface IP address. Step 2, configure a radius server. Configure a WLC with the radius server IPv4 address. Use a shared secret of RAD secret. It is easy to configure. So we will go to management host, wireless LAN controller. Here we will go to security. We are using the latest version of packet tracer and we can see there is a small delay in this wireless LAN controller. Okay, now here we will radius authentication servers. We will create new. Then we need to give the IP address of our radius server IP address. So here we can see our radius server. Let me check the IP address 172.16.1.100. Better I will copy. Then paste here. And also the specified IP address, it's RAD in caps, then secret. So confirm shared password, RAD secret. So let me apply it. Next is configure a wireless LAN. Create a new wireless LAN, name it WLAN 10 and configure the SSID as SSID-10. Okay, we will do that. We will go to wireless LANs. Okay, now create new. We will click on go and we need to create a new wireless LAN. Profile name as specified WLAN space 10, then SSID SSID-10, then ID 10. Click on apply. Then we need to configure, we need to enable this WLAN 10. Okay, here in general WLAN 10 SSID 10. So status we will enable it. Then here in interface group, here we need to give VLAN 10. So all these instructions are given here. the wireless LAN should use the VLAN interface that was previously configured, and configure the WLAN to use the WPA2 security policy and .1x authentication key management. Then configure the WLAN to use the radius server that was previously configured to authenticate wireless users. Then open the advanced tab and scroll down to the Flex Connect sections, which is most important. Activate Flex Connect local switching and Flex Connect local auth. Verify that the WLAN is configured and operational. So we already created this WLAN 10 with the SID 10, and we enabled it, and we choose here interface WLAN 10. And we'll go to security. Here we will choose WPA plus WPA2. Then we will choose this WPA2 policy. Then 802.1x enable. Then in AAA servers, we will choose our server. AAA server we already created. Then in advanced, here we can see Flex Connect local switching and Flex Connect local auth. Then we will click on apply. Next is configure a DHCP scope for the management network. Configure a new DHCP scope to be used by the LAPs and other management device on the network. Name the DHCP scope wide_admin. Then start the scope at address 192.168.100.240. End the scope at address 192.168.100.249. Other information that is required can be found in the addressing table. Okay, we will configure this DHCP scope. We will click on controller, where we get this internal DHCP server, so that we can create this DHCP scope. Here we will click on new, and we need to create this wired_admin. We will give the name as wired_admin and click on apply. Now we need to set this pool start address, pool end address, network, all this. So we can click on this wired_admin, so that we can configure those information. Pool start address 192.168.100.240. Then pool end address, it is 100.249. Network is 100.0. Then net to mask, in this topology itself they given these details. Here we can see management 192.168.100.0/24. So we given the net to mask, then a default routers. So it's 192.168.100.1. We can click on apply. Next is step 5, configure an SNMP server. Configure an SNMP server to receive traps from the WLC. Use the community name branch wireless, then use this address 172.16.1.100 as the server address. I will copy this for easiness. Then coming to, so here we need to go to management. Here we can see SNMP trap receivers. Then we need to click on new. So here we can give the name. We already copied it, community name branch dash wireless. Then that IP address also they specified 172.16.1.100, 172.16.1.100. Okay, so click on apply. Configure the wireless host. Okay, so the configuration in this wireless LAN controller is completed. So just we will click on this save configuration, and then you can click on OK. Successfully saved all configuration. Perfect. Then configure the wireless host to connect to the WLAN. Create a new wireless profile on the host. Use the name WorkNet for the profile. That can be done. Wireless host. We need to go to PC wireless, then profile, then new. Here we will create this WorkNet. Okay, click on OK. Right. So configure the profile for the SSID of the WLAN. Use enterprise authentication with a username of user1 and a password of user1 pass. When you are finished, click connect to network. It will take time for the connection to be established. Okay, we will do that one by one. So after creating this profile, we will go to advanced setup, and here we can see SSID-10. Okay, we'll click again on next. Obtain network settings automatically, DHCP. Okay, that's fine. So we'll again click on next. Then wireless security. Yes, here we should choose WPA2 enterprise. Then click next. Now we can set the login name and the password as they specified. So login name is user1. Then the password is user1 PASS. Then next, save, and here we can see connect to network. Click on that, and we need to wait some time. Yes, now we can see you have successfully connected to the access point. Here we can see the signal, and we can see in IP configuration this wireless host is received its IP address. Subnet to mask, default gateway, and DNS server. Perfect. Now here we can see our completion status. It's 100%. Now friends, if you get any doubt, you can contact our team. All the details given in the description below. Also, if you wish to get any technical support, you can contact us. Consider subscribe. Stay connected. We will meet again with the next video. Thank you.